In question 6 we have a 12 volt battery of negligible internal resistance connected to lamps P and Q in parallel. In A we're told P is rated at 12 volts 36 watts and Q 12 volts 6 watts. In part 1 we need to find the current in the battery. Well, for this we can use current is power over potential difference. The total power will be the 36 watts plus the 6 watts over the 12 volts. This gives a current of 3.5 amps. In part 2 we're asked to find the resistance of lamp P. Well, resistance is potential difference squared over power. Putting in the values gives a resistance of 4.0 ohms. In part 3 we need to find the resistance of Q. Using the same equation we get a resistance of 24 ohms. In B we need to state and explain the effect on the brightness of the lamps in the circuit if the battery had a significant internal resistance. Well, a high internal resistance would reduce the current in the circuit due to a greater overall resistance of the circuit. Therefore the lamps would be less bright. In C we now have the lamps connected to the 12 volt battery in series. In part 1 we need to explain why the lamps will not be at their normal brightness. Well, the resistance of the circuit is now higher, so the current through the lamps is reduced, making them less bright. In part 2 we need to state and explain which of the lamps will be brighter, assuming the resistance of the lamps doesn't change significantly with temperature. Well, both lamps have the same current, but as lamp Q has the higher resistance it will take a greater share of the potential difference, and Q will therefore be brighter.